All right, in the last time we talked about adding and subtracting polynomials. So today we're going to talk about multiplying polynomials. Okay? Notice in your book on page 222, which is obviously not where I am. Sorry about that. 222. This is where your homework's coming from. Okay, this page right here. You do have some adding and subtracting problems to do. Okay, you're doing problems number 4 through 6, 4, 5, and 6 right here. So those are adding and subtracting. Excuse me, adding. And then you have 12 through 17 to do. You have some subtracting, and then you have 2 word problems. And then you have this crazy problem right here. We'll talk about that in just a second, what we do on that. Okay, and then you have some problems in your workbook. Did you notice that as well? Book and workbook. And in your workbook, you have problems on page 116. Okay, and you're doing problems 4 through 11. These are multiplication problems. Okay, so you have one multiplication problem in your book, and then you have these problems right here. Okay, so let's go over polynomial multiplication. Is this something you've ever done before? Yeah, absolutely. Okay, absolutely. This is what you've done before. So, really simple one to start with. 2 times 5x plus 3. What do we do with the 2? We distribute. 2 times 5x. Does anybody know what 2 times 5x is? 10x. What's 2 times 3? 6. And then we're done with that problem. Any questions about that? Okay, so let's step it up a little bit. Let's say 3x times 4x squared plus 6x minus 3. Are we still distributing here? Yes. 3x times 4x squared. Well, what's 3 times 4? 12. This is where you have to remember. What's x times x squared? So if I say x times x squared, what's x squared the same as? X times x, so don't I really have x times x times x? So what should that equal? X cubed. Now people say, well, I have 3 x's, so that should be 3x. Except I'm not adding, I'm multiplying. Only when we multiply is the only time we can ever mess with the exponents. Multiplying or dividing, I guess I should say. Okay, but when we're multiplying, which is all we're doing today, right? Multiplying is when we can mess with the exponents. When I'm multiplying like bases, what do I do with the exponents? Add them. So if I'm multiplying the like bases here, which is x, I have 1 plus 1 plus 1, which is 3. Or I could even stay up here and say 1 plus 2, still to the 3rd power, right? So what do I have when I have x times x squared? X cubed. Now if I multiply that term, what do I have? 18x squared. 3x times negative 3 minus 9x. Very good. Okay? So what happens if it's a little bit more difficult looking? Things that are difficult looking are not always difficult, are they? Okay? 4x minus 5 times 3x plus 2. I cannot just combine the terms because I am multiplying. I'm not adding or subtracting. I'm multiplying. So I have to distribute. Now, when you were little baby math students, you said, oh, I'm going to FOIL this. Because you remembered to do first, outside, inside, last, right? FOIL. Okay? We're not little baby math students anymore. We are Algebra 2 students. And as Algebra 2 students, we don't FOIL anymore. If you need to think of that in your head, that's great. But I need you to know the actual mathematical property that we're using here. Okay? And it's called the distributive property. Okay? We are distributing the 4x to the first term here and to the second term here. The 4x. So what is 4x times 3x? 12x squared. What is 4x times 2? Plus 8x. Okay? Then I have to do the same thing, except this time with the second term. The second term times this first term, and the second term times this first term. What is negative 5 times 3x? Now I'm going to write it right here. Why am I going to write it right here? Except I'm going to write negative like it's supposed to be. Why am I going to write it right there? Because I've got to combine them in a minute, and I want to keep them close to each other so I remember what to combine. Okay? So what's negative 5 times 2? Negative 10. So now when I go to combine these terms, I've got my like terms. Remember, this was like in the video where we added or subtracted horizontally, right? Okay? So I have 12x squared. What do I have here? Negative 7x squared. I got an x and an x. But I'm adding or subtracting, right? So I do not mess with the exponent. I leave it alone. Minus 10. Okay? Yeah, and then you're done. Absolutely. Okay? Now, this is probably the most important problem that I'm going to do for you right now. Not because it's the hardest, because it's one of the easiest, but if you're not paying attention, you will do it wrong every time. And I will want to, like, kick you in the shin every time. Okay? X minus 2 squared. If you're not paying attention, every single time you will tell me the answer is x squared plus 4. And every single time you will get it wrong. Okay? This is one of those things that's really super important because this is not the only time we use it. We're going to use it in 3 or 4 different lessons between now and the end of the year. So can we get it right now? So I don't have to do any shin kicking. Okay? What is it the same as when I square something? Multiplying it by itself, right? So this is really x minus 2 times x minus 2. How is that different than this problem up here? Yeah, it's not, is it? I have to distribute here and get x squared. I have to distribute here and get negative 2x. I have to distribute here and get negative 2x. And I have to distribute here and get plus 4. It doesn't matter where I put that, on this line or that line. But guys, the point is, when I combine all my like terms together, I actually have a third term. I don't just have x squared plus 4, which is what I would get if I squared this term and squared this term. I have a third term. And if I leave this out, I will get it wrong every time. So can we just decide that we're not going to leave it out? Is that okay with you guys? Then let's do another one. Five squared. Does this look harder? Because the numbers are bigger? It shouldn't be, right? Same exact thing. 6x squared minus 5 times 6x squared minus 5. What is 6x squared times 6x squared? 36. Oh, are we allowed to do that? Yeah, absolutely. And not only are we allowed, we have to, right? We don't want an exponent police coming for us. 6x squared times negative 5. Negative 30x squared. Negative 5 times 6x squared. Negative 30x squared. Negative 5 times negative 5. Plus 25. So when I add those together, I get 36x to the 4th minus 60x squared plus 25. Any questions? Oh, that's a good question. Let's do one like that. So if you have x plus 5, x plus 5 times x minus 1 times 2x plus 4. Let me ask you this question. What if you had 3 times 2 times 6? What would you do? Would you say 3 times 2 and then 3 times 6? So I combine these two. I'd multiply these two and get 6. And then multiply the third term, right? How is that different than a problem like this? It's not, okay? So let's ignore this first. Ignore this one. And just do x times x squared. X times negative 1, negative x. 5 times x plus 5x, and 5 times negative 1. negative 5. So again, I'm ignoring this for just for a minute. So I have x squared plus 4x minus 5, right? That's what that ended up to be. Now I still have this, 2x plus 4. And now I do it again. X squared times 2x. 2x cubed. What's x squared times 4? 4x squared. What's 4x times 2x? 8x squared. And 4x times 4? 16x. And then I have to do the 5, right? It's weird because there's 3 this time. Guys, this is why we don't quote-unquote FOIL things in Algebra 2, because it's not always just 2 terms. Sometimes we have 3 terms. Sometimes we might have 4, sometimes 5. We don't want to make up some weird, crazy word just so we can have FOIL. Okay? So this is why we say distributive property now that we're older and wiser. So negative 10x and negative 20. Now I just have to combine all my like terms. Guys, and let me make this clear. You can absolutely write this vertically. You can all write it all in one row. I like to write things were above and below each other just so I can keep track of everything a little bit easier. That's just a personal thing for me. That's not a requirement for you. Okay? 2x to the third plus 12x squared plus 6x minus 20. Yes? Questions? Okay, I think that pretty much, oh no, and let me show you one more. I was going to say I think that pretty much covers everything in your homework, but let me show you one more because I don't want you to be, like, frightened. 3x minus 8 times 3x plus 8. Distribute, right? Same old thing that we've been doing. What's 3x times 3x? 9x. Squared. What's 3x times 8? 24x. What's negative 8 times 3x? Negative 24x. And negative 8 times positive 8? Minus 64. Are we always supposed to get 3 terms? Because I didn't. Is that okay? Is that allowed? Yeah, I didn't do anything wrong. I distributed like I was supposed to. I combined my like terms right here. I have a positive 24x and a negative 24x. That's 0. That's okay to end up with a term that's like, I don't have an x term, do I? I have an x squared term and I have a constant, but I don't have an x term, and that's okay. All right? All right, do you have any questions about any of these? Okay. Now, if you look real quick in your workbook, the instructions on 10 and 11 says use Pascal's triangle to expand this. We obviously don't have time to work on that today because of our shortened day. Okay. Expand it like you know how to expand it, and we will talk about that later on. Okay. Have a great day.